Okay, 13 from August 2017. Number 13, August 2017. All right, when I continuously rotate, the object I get when I rotate it has a volume of 150 pi. Anybody know what I get when I continuously rotate a rectangle? Cylinder. They tell me the volume is 150. Anybody know where I can get, forget about what it is, where I can get the volume of a cylinder? That is not one you have to memorize. It's on the reference sheet. Pi r squared height. Okay, and it tells me it's 150 pi. So I'm going to make this easy on myself right away. What's going to cancel on both sides? Pi. So really what I'm looking for is what values, when I rotate around these three choices, are going to give me, when I square the radius and multiply it by the height, 150. Okay, ready? So when I rotate around the long side, I rotate around this long side, going this way, this way, this way. The radius now would be your 6, and your height would be that 10.
Wouldn't the radius be 3?
Nope.
Wasn't the 6 the diameter?
But I'm rotating around this line right here. Okay? See what I mean? All right? So now I go 6, what's that, 360? No good. Oh, I'm looking for 150. Good. So what happens if I rotate around the shorter side? These will flip, right? So 10 squared times 6, 600, not going to cut it. All right, so those two, not going to cut it. What about the vertical line of symmetry? Vertical line of symmetry now. Now it'll cut that 10, radius of 10 into 5. So I'll go 5 squared times the 6, and that'll be what, 25 times 6? If I have 6 quarters, I have 150. Okay? Good? Okay. More from that homework. Anything else on the assignments you want to go over? How do you think you're going to do, by the way? You're going to be the guy that finally breaks my curse? Finally breaks the curse? 4 or 5 years of the exam, you'll be the one, Frank, that finally gets the 100 for me? What should I do, by the way, if somebody gets 100 in here? We're on this donut kick, huh? I think it should be like an individual thing. Like you could come in and discuss it with me, what you want to do. Not like a class decision, because, you know, if somebody gets 100, then that somebody else gets one and they don't want the same thing. They want an individual thing. We can talk about it. That's fine. If you really want to. Like in the past, I've had before this exam came out, the older geometry exam was a lot easier to get 100 on. I'd probably have like 3 or 4 a year. People get 100 on it, and it was like I got pied in the face a couple times.
Wait, do you have to wear Buddy the Elf costume?
Yep.
I saw a picture of that
Yeah,
one.
it's with they're graduating this year. Trey Scroy and TJ Trossett both got 100, and I had to wear a Buddy. What's that?
Daddy goes, you got 100?
Yeah, I know, exactly. Yeah, that's what I thought too. And I think they sat next to each other, so I think something was going on. But yep, they got 100 on the old geometry exam, and they chose to have me wear a Buddy the Elf costume, and they came in. We took pictures together. It was real fun. I had to teach a class in it. Yep, 43 minutes wearing that thing. Yep, pied in the face. This one right here, girl got this made, and every time she came in the year after, I had to put it on and just say my math ability was inferior to hers in front of whoever was in here. So we can discuss it. I'm open for a lot, especially getting 100. That's a pretty big accomplishment. So, and being the first one on this exam too. So we could talk it over if you're interested in that. All right. Next, anything else on the homework here? Hi, Carolyn. 34. Oh, Kira and her poster. Yep. Okay, first thing is make sure you know what you're finding the area of. It says determine and state the total area of the poster and the frame. So literally, it's this whole thing right here. We're finding the area of this whole thing. So what I needed to do first was find the length and the width of this poster right now. Find the length and the width. All right. How am I going to find this length right here? Well, I could find the length of the poster inside, then add on, anybody know what these distances are here? 4, yep. So whatever it happens to be, this length, wherever it happens to be, literally just sitting there right now. Just chilling out, Mickey. Good man. There we go. That was my 6 and 10 rotation, by the way. I'm going to take this side of the poster here and add 8 to it, and then I'll take the width of the poster and also add on what to it? 8. But I need your help right now actually finding the width of the poster inside and the length of the poster. What shape is the poster? Tells you at the beginning. What shape is it? Square. Okay, properties galore. Properties galore. If you forget any of the properties, they're in your cold hard facts packet I gave you yesterday? Yes, yesterday. What's going to help me out here? What else can I add in here if it's a square? Right angles. What do you know about these two sides? They're congruent. So you could do Pythag. I'm going to do it a little bit differently, though. What's across from those congruent sides? Congruent angles. Anybody want to get more specific on the angle measures? It's a 45, 45, 90. Yep. I also heard from 8th period yesterday, you could also draw in the other diagonal and make a right triangle, bisects each other, and do Pythag with that right triangle. It's up to you. I just wanted to do the 45, 45, 90 rules and show you something real quick. X radical 2. Where's that 58 across from? It's across from the 90. That's one of the worst places we could be, but we can handle it because we're in honors geometry. 58. How do I go backwards? What do I have to do with the 58? Divide it by radical 2. No radicals in the denominator. You'll thank me next year when you get to this. What do I do to get rid of it? Multiply top and bottom by radical 2. 58 radical 2. What's in my denominator? 2. 58 divided by 2. 29 radical 2. Now look, we're at this point in the year where I can give this little tips. I would never give it to you during the year because it's an easy way out. You don't need to actually do all this stuff right here to get the final answer. If you're ever going backwards in a 45, 45, 90 triangle, just take that number. How do I get from 58 to 29? Divide it by 2 and throw a radical 2 in front of it. Done. So if this number was 100, guess what the side across from 45 would be? 50 radical 2. Okay, so you don't need to show me all this. Just divide it by 2 and put a radical 2 in front. So this side ends up being 29 radical 2. So does this side, 29 radical 2. Carolyn, you good so far back there? All right, so the area of the whole thing now. Anybody, how long is my width going to be? 29 radical 2 plus 8. Can I combine those two? Absolutely not. And what is the length? 29 radical 2 plus 8. And it says round to the nearest 10. Plug the darn thing in your calculator. You're on your way. We are. We're okay? Questions? Again, this is one way to do it. If people use Pythag, you could use Pythagorean theorem. Again, just like I told you at the beginning, somebody in 8th period yesterday said, hey, I'm going to draw this other diagonal in here. I know the diagonals are perpendicular. They bisect each other, 29, 29, 29, because they're congruent. Do Pythag, boom. All right, multiple ways of doing this problem. Anything else you want to look at? Yes, 15, everybody. Because I'm going to go possibly 2 proofs with you today. 15, perfect. This is why you need your calculator back in degree mode for problems just like this. Okay, find the angle of the ramp right there. All right, I got a right triangle, so now I'm thinking sine, cosine, tangent. Could you use law of sines too? Yes, you could. I think it's easier to use a little SOHCAHTOA here, since it is a right triangle. So now somebody, here we go, figure out what's the 1 acting as. Opposite hypotenuse or adjacent to the angle X I'm finding. That's opposite, and how about your 12 here? Adjacent, what am I going to use? Tangent. But there's a little catch here. Because you are finding an angle, you are not cross multiplying. What do I need to use on my calculator to find any angle? Inverse. So inverse of tangent, and then I plug in 1 over 12. Inverse of tangent, 1 over 12. I wonder if they did, just one real quick here, son. I wonder if they're this nasty. Let me just check the people who do these exams. No, they're not. If you left your calculator in radian mode, that answer is not up there. Lucky you, so make sure it's in degree mode, though. Okay. Good, Madeline? Anybody else? Yes, let's get to mine today then. Here we go. 33, going to start you off with the proof. Good morning, everybody. 33. Not only a proof, a circle one, our favorite unit. Don't touch a thing. Everybody go look right at the proof statement right now. Anybody know what type of proof this is going to fall under? If I'm proving two ratios are equal. Similar triangles. Yes, this is going to be a similar triangle proof. We'll talk about all the great reasons in a second, but you're going to prove two triangles similar. Probably by what method? Angle. So we're going to first identify the two triangles we need to prove similar, and then see if we can find two pairs of angles that are congruent. All right, how do I find which two? Well, it's not too bad here because I believe there's only two in the diagram, but use your proportion to figure out. I got side BC, ding, ding, there it is. And I got side CA. Oh, must be that triangle. Combine with AB and EC. Let's see, EC, oh, must be this triangle as well. So it looks like those two triangles I'm going to prove similar. Okay, everybody stop what you're doing. I just want to tell a quick story. 2 years ago, kids had to do a proof. If they did not write in all the givens, you got a point off. Like if you pull one of these bad boys, you got a point off. If you pull one of these bad boys and write a big G for given, you get a point off. Write the givens in, please. I know it may be tedious, especially in this one. Write them all in. Okay, write them all in, please. You can't leave until 2 hours, and you have 3 total hours to take it. So I think you can write in the givens. All right, so don't be that kid that gets a silly point off. There goes your 100, right? Now you got a 99 because you didn't write in your givens. Okay, I'm sorry. For time's sake, I'm not practicing what I just preached. I want to get going. But as long as I told you guys, write them all in. I will mark it on my diagram, though. Chord BC is parallel to chord or secant ADE. Perfect. I got a tangent line. Perfect. Diameter. I don't need any more markings. All right. Can you guys find me a pair of angles? All right. Any pair of angles up there that has to be congruent. Let's roll. Frank. Okay. He is claiming BCA and which other one? DAC are congruent. He is correct. I need somebody else to tell me why. So I have angle BCA congruent to angle CAD or CAE, either one. Okay, somebody else. Why is Frank correct there? Ella? There you go. I have parallel lines, and that must mean the alternate interior angles are congruent. All right, need another pair, and this pair is not going to come easy. Use some circle facts for the next pair. Hi, Katie. Yes, she's got the correct angles. We're going to say they're congruent at the end, but I need to know why they're congruent, because they're actually congruent for two different reasons here. Anybody know what? First, let's go to CBA, the angle Katie said here. CBA. Anybody know anything about CBA? Maya? Darn right it is. It's a right angle. So I'm going to say that first, that angle CBA is a right angle. Anybody know why it's a right angle? Hi, Evan. Okay, first, hold on. I'm sorry to stop you, but you got to say that. You can't say an angle. All right, you got to say it's an inscribed angle. Inscribed angle. And what do you know about that inscribed angle, Evan? Go ahead, continue. Drawn to a diameter. You could also say drawn to a semicircle. Either one's fine. Drawn to a diameter is a right angle. Got to say it's inscribed. Gotta. Just can't say angles drawn to or chords drawn to diameters. No, inscribed angle drawn to a diameter. All right. And Katie, what was the other angle you told me about? CBA and ACE. That is also a right angle, but for a different reason. That is also a right angle, but for a different reason. Anybody know why that one's a right angle? Go ahead, Madeline. Diameter drawn to, be careful. I don't want you to say diameter drawn to a tangent. I want diameter drawn to, what's this point here? Point of tangency. But, whoa. The theorem doesn't say it's a right angle. What's the theorem say? These two are perpendicular. That's what I need to say first, is that AC is perpendicular to CE. I want to make sure you guys get the wording correct so you don't get silly points off. A diameter, you could also substitute in what word instead of diameter? Radius instead. A diameter drawn to, not a tangent. You don't say a diameter drawn to a tangent. Diameter drawn to the point of tangency. Is perpendicular to the tangent. That theorem does not say it's a right angle, just says it's perpendicular. Now you guys can go ahead and say angle ACE is a right angle. Reason for that now. No circle fact here, just old school. Perpendicular lines form right angles back when we liked each other. Now tell me, what about your right angles? They're congruent. Angle ACE congruent to CBA. Right angles are congruent. Do we have two pairs of angles congruent? Yes, that makes the triangle similar. So make sure we get the order right here. If I go triangle ABC. Similar to, let's see if I go ABC, what do I got here? ABC and ECA. Is that correct? ECA. You want another quick fact about this year? That'll just start revealing everything now. All my secrets now. I never checked if you wrote it in the right order or not, and nor will the Regents exam when we correct them. They don't care if you write it in the right order. I never did either. But I had to show you that it had to be in the correct order because when the Regents exam, you know, in the given says this triangle congruent to this triangle, the corresponding sides always match up. Did I ever check it with you guys? No, not at all. Will I check it when I'm grading the Regents exam? No. Will all the other teachers who are grading your exam check it? No. Okay. So I'll just start revealing all these facts as we leave each other here. Because again, once I pick up that test, I don't care who you are. So, and then finally, BC over CA. Is equal to, what do we got? AB over EC. Anybody got the old reason here? Now that the sides are in the proportion when I proved a triangle similar. CSSTP, that is fine. Hey, any abbreviation we've done all year, in all seriousness, is fine on the Regents exam. You start making up your own, I can't vouch for you. All right, that is fine though. Quickly, let's just review every possible scenario. What if I went one more step? One more step and said BC times EC equals CA times AB. Product of the means equals product of the extremes. Yes, and that's as far as you can go in a similar triangles proof. Questions? Now you're all devastated that I never checked, I'm sure. Okay, but now you're better for it. You're tougher for it. You're tougher, mentally tougher for it, which is what I groom in my students. Here we go. 12. Oh, he's giving me another circle problem. You're darn right I am. Is it?
Yeah.
Must be, yes. Sorry, thank you. Must be the new June one. I am hoping that you guys are keeping track of these exams because I still have another one to give you. I'll let you try this one out on your own. This is the second one we've done now with review. I just want to make sure we are solid on this one because I have no idea what questions will be on the exam, but if I had to predict, this definitely will be part of it. Putting an equation in your circle form and then picking off the center and radius of it. Anybody getting nervous because there's nothing with the x squared? Leave it, don't touch it. That means you only have to complete the square once on the y's. All right, you don't need to touch it. Just leave it x squared. So that automatically means, what do you know about your x coordinate of the center? It's got to be 0. That doesn't eliminate anything for me. So let's keep going. Y squared minus 12y. What's your new c value when you complete the square? 36. Yep. Half your b value squared, 36. Make sure you add 36 to the other side. Don't move it over. Keep it there. Just add 36 to the other side. X squared, don't touch it. What's the y? What's this going to factor into? Y minus 6. And then on this side, you end up having 16. A lot of traps in your multiple choices. A lot of traps. Your center now. 0, 6. Change the sign. And your radius, remember, that's radius squared, not what radius actually is. So your radius would be 4. Boom. Bless you. We feel confident with these now? We feel pretty confident we can change it on our own and find center and radius, maybe even graph it if we have to. Maybe find the, here's another thing. I'm just start throwing out different scenarios. Could you find the area of this circle? Could you find the area of this circle? What's the area formula? Pi r squared. Do you know the radius? Okay. All right. Okay. 28, a little volleyball action. Hey, fun fact, when volleyballs are purchased, they're not fully inflated. There you go. Just not taking a geometry exam, answering some facts as well. The volume of that partially inflated one is 180 cubic inches, and we're talking about spheres here. And when fully inflated, there's the new volume. How much did the radius change? Okay, by how much did the radius change? So we're talking about volumes of a sphere. Where can I find that one? Formula reference sheet, absolutely. There's one right in this exam for you. So let's go partially inflated, PI, fully inflated, FI. Anybody want to give me a heads up on the volume formula for a sphere? 4/3 pi r cubed, right off the formula sheet. Volume of a partially inflated one, 180 inches cubed equals 4/3 pi r cubed. You're solving for the radius. What are you guys going to do on both sides there? I'm interested to solve for the radius. Multiply. I would multiply. I'd get the fraction out of there just because I'm not a big fraction guy. But so I'd multiply both sides by 3/4 first. But that's up to you. Whatever you do at the end here, do not round. Do not round at the end. Keep that full decimal rocking. And at the end, where you're going to take, you're not taking the square root, you're going to take cube root. Where's it located on the calculator? Because I can't answer that come test day. Math number 4. Yep, can't answer that come test day. And then you can go over and do the same thing for the fully inflated one, which is now 294. And then I'm interested to see what you guys do at the end here. I see most of you doing what you need to do. Some of us, though, might go the other direction. How much does the radius increase by? What are you going to do with these two radii? Yeah, subtract them. I was a little nervous maybe some of you would divide because that's what we kind of been doing with all these volumes in our volume unit. But yeah, you're just seeing by how much it increased. So you're going to subtract these two radii from each other and round to the nearest 10. And what do you end up with? Nearest 10th? 0.6 inches. Yep. And if you're wondering, yes, I always cared if you put units on. Okay. Some of you will find that out when I give back the test tomorrow. I did care. Questions? The Regents, not so sure. So don't risk it. Don't risk it. All good? Cube. All right. Yep. Transformations, big part. 30. So they're giving me AB is congruent to DE. They're giving me AC congruent to DF. And they're giving me A congruent to D. Very different than the problem we did yesterday as a class. I need you to come up with the sequence of transformations that maps these two triangles on top of each other. Okay. How would I get triangle A to match up with D? How would I get AC to match up with FD and AB to match up with ED? And I'm doing this for a reason. You can tell me rotation, translation, whatever, but you have to get specific. Anybody want to start with one transformation I could possibly do here? Even if you just generic transformation I could do. Okay, a rotation. If you're going to tell me a rotation, you got to tell me what direction and the center of rotation around where you're rotating it. And that's going to be pretty tough here because I'm not given a graph. I can't turn my paper at all. So here's what I'm going to suggest if it's just wide open like this. Pick a vertice on the pre-image you're rotating around. Okay, so where do we want to rotate it around? Point A, B, C. It doesn't matter in this case. We're not going to be wrong. Point B. Okay, so let's rotate. Triangle ABC, which direction? Clockwise or counter? Because you can't give a degree measure here. It's impossible. Clockwise or counter, but you can give clockwise or counterclockwise. Okay, so rotate triangle ABC clockwise around point B. The point you pick now will be pretty darn important in the next step. What do I still have to do with it to make sure they map up? I rotate it clockwise around point B. I still got to do what to get it on top? Translate. And if you're going to tell me to translate, what do we always translate along? Anybody remember? A vector. Okay? And the vector in this case, because you picked point B, the vector is going to be B. What does B match up with here? E. So you have to slide it, translate it along vector B, E. If you chose to rotate around point A, what vector would you translate around or across? A, E. Okay? So we'll finish that one up tomorrow though. Because this is pretty important. I want to make sure we get the full idea. Remember, review sessions start tomorrow after school. Late buses are available.